Hello students, welcome you on the topic of convolution codes. Convolution codes are going to produce output for a single input generation. The convolution codes can be worked on encoder side as well as on the decoder side. This convolution code uses the best decoding algorithm which uses the maxi likelihood algorithm, which we call it as Worthy algorithm in the receiver segment. Hence, convolution codes are playing a vital role in almost all the modern wireless communication system. How to generate a convolution code? First, we are going to discuss the topic under transmitter segment. Therefore, it is a encoder circuit. To create a circuit, we need to know what is the dimension of a convolution coder. Input is going to be only 1 bit. We are going to generate 2 consecutive outputs using shift registers. Therefore, the dimension is n, k, 2, 1. So, come over here. So, it is 2, 1. That is a dimension, 2. The last 2 indicates how many shift registers are used in the convolution encoder block diagram. So this is the generalized block diagram shown for a convolution encoder. We have 2 shift registers. The D is going to be denoted as the 2 shift registers, and output of the shift registers are S0 and S1. We are going to create a final output C0 and C1. C0 and C1 depends upon the 3 information supplied to the system with the help of a shift register. So how to generate C0 and C1? C0 has been generated from a binary adder taken with 2 inputs, input and another one from S1. Similarly, C1 output is generated from a 3 input binary adder, input, S0, S1. So this is how we define a block for a convolution code. Apart from the dimension parameter, we need to know what is the efficiency rate calculation for this particular circuit diagram and what will be the constraint length. Rate efficiency is defined by the ratio of K by N. K we already know it is 1, N is equal to 2. Therefore, the rate efficiency of this particular circuit is half. Constraint length says about how many sources of output you can see. If I supply 1 input, I can have this as 1 input, this is the next input, this is the next input. So we'll have totally 3 outputs to be taken. Therefore, the constraint length for this convolution encoder is 3. So from the circuit given over here, we are going to derive a truth table which is going to say how the outputs are being generated for a single input system with the help of a shift registers. We move on to the truth table. How many inputs are there? Only 1 input you can assume. Okay, so the inputs can be either 0 or 1. But this shift register output is S0 and S1. So the 2 states can have 4 possible combinations. So we have written the combination as 0, 0, 1, 0, 0, 1, 1, 1. So these are the combinations taken with respect to the shift register output. Input you are going to have only 2. Either it is 0 or 1 combination for this state. For the next state again 0, 1. Similarly for this state 0, 1 input. 1, 1 state 0, 1 input. So how to generate your output? C0 and C1 are the output condition generated from a shift registers. So C0 is nothing but addition of input bit and S1. So add the 2 information, input and S1, 0, 0, you will produce 0. What is C1? It is combination of 3 information, S0, S1 and input. So it is 0. S0 dash and S1 dash says about what is the next state level. So this is present state. The last column is the next state. How to calculate your next state? Now we will take the next condition for input 1. Take the state as 0, 0. So it is 0, 0. Now you are going to take C0. C0 is S1 and input. Input and S1, 0 plus 1, 1. If you want to take C1, it is 0 plus 0 plus 1. So 1. How do we come across next state? Next state says that you push this input. Now it is a shift register. Shift register is nothing but a delay register. You have initially 0, 0. This is 0, this is 0. You are having input as 1. You push the information. So this 0 will go over here and this 1 will go over here. So I'll show you. First is 0, 0. Okay, the condition is 0, 0. Now we have input 1. As you go for the next, this is the present state. Okay, as you go for the next state, this 1 will go over here. So the condition will become 1. This 0 will be going over here. So this condition will become 0. That's what it has been shown 1, 0. Similarly, we have to do for the next condition levels for filling up the truth table. So take it, what is C0? C0 is addition of S1 and input 0 and all three 1. If you want to push, you push the 0. This will become 1. Clear? Now you go for this condition. It is 2. You are going to add S1, 1. If you are going to add 1, 1, it will become 0. Now we are going to go for the next state condition. Next state condition is input will be pushed to S0. 1. 1 will be pushed here. So 1, 1. Come for your next state 0, 1. C0 is S1 and input, add it 1. You add all these 3, you will get it 1. To find out your next condition, push this input to S0, S0 to S1. Therefore 1 will go off, you will get it 0, 0. Again come for this 1, 1, you will get it 0. Again you will have all these 3 condition added, you will get again 0. To find out your next state, push this input over here. 0 will push to here. Therefore, 1, 0. When you come for your next state, 1, 1. Take the input 1. When you add these two first, these two, you'll get it 1. You add all 3, you'll get it 0. To find out your next state condition, take this input, come to this level. 1 will be pushed here, 0 will come. Therefore, it is 0, 1. Again, take 1 as your input, take the level 1, 1, you add all, first you add 1, 1, it is 0, add all 3 ones, it will become 1. Now you push the state, even if you push all, it is 1, 1, therefore you get it as 1, 1. This is called as the truth table, where you are able to develop a encoded output for individual bit transmission depending upon your shift register's output. Okay, so 0, 0, 0, this is called as the constraint length. That is called as the constraint length. Now this encoder output is represented by using a diagram called as the Trellis diagram. So Trellis diagram will say about how we are able to develop a encoded output under convolution coding algorithm. So we'll take the state, all 4 states, name it as A, B, C, D. Okay, so A, B, C, D. A is defined as 0, 0, B is 1, 0, C is 0, 1, 1, 1. Now you will look into your truth table, then we have to do the circuit. 0, 0, input is 0. Now we are going to compare the truth table and draw the Trellis diagram. First we'll take the state 0, 0. Okay. From 0, 0 it is pushing to next state 0, 0. Under the condition input is 0. Output developed is 0, 0. So usually we are going to draw the Trellis diagram by using the inputs A, B, C, D as defined by the states. Input, again you can take same thing over here. Now we are going to draw a tree like format. 0, 0 is pushed to 0, 0 itself. Correct? 0, 0 is moving to next state 0, 0 itself. Under the condition input is 0. developed an output of 0. So 0, 0, 0. Therefore, this is input and this is the C0 and C1 output. It is moving from state 0, 0 to the same state 0, 0. Next one, 0, 0. Input is 1. Output developed is 1, 1. But it is moving to the state 1, 0. Therefore, you come here to Trellis diagram. A 0, 0 is moving to the next state 1, 0 under the condition of input 1, output developed C0 and C1 is 1, 1. Similarly, you have to do for this condition. So 1, 0, 1, 0, when you go to the truth table, under the input 0, it is moving to next state what? 0, 1. It produces an output of 0, 1. Similarly, 1, 0, it is 1, it will move to 1, 1. So come over here to Trellis diagram. 1, 0 is moving under the condition of to 0, 1. 1, 0 is moving under the condition of 1, 1. For the first one, it is input is 0, output produced is 1, 0. And for the next one, input is 1 and output produces 1, 0. So the things which have been denoted like this, it is nothing but input bar output. These are the present state and these are the next state. This is how we can convert a truth table into a Trellis diagram. So once the Trellis diagram has been defined, we can say that output is being generated under the transmitter circuit. Next condition we'll take is the level 0, 1. If the input is 0, it is moving to 0, 0 state. If the input is 1, it is moving to 1, 0 state. And these are the input and output combinations. Okay, so we'll move on to the Trellis now. 0, 1, if the input is 0, it is moving to 0, 0 state. If the input is 1, it is moving to 1, 0 state. What are the output and input represented for that levels? 0, 1 to 0, 0 is input 0, output is 1, 1. 0, 1 to 1, 0, input is 1, 1, output is 0, 0. Similarly, go for the next condition. State is 1, 1, input is 0, it produces an output 0, 1. 1, 1, input 1, 1, 1. It is the output values representation. So representing this particular state level in Trellis diagram, 1, 1, if the input is 0, it is moving to 0, 1 state. If the input is 1, it is moving to 1, 1 itself. Input is 0, 1, 0 output. Input is 1, output is represented 0, 1. Therefore, the input and output are going to be the columns representing second and third column. The levels of input and output state is representing first column and last column. This is how we can mention a truth table converted into a Trellis diagram. This is the output of an encoder circuit, which is nothing but a convolution encoder. Now we are going to represent a state transition diagram from this Trellis. And this state transition diagram is identically equivalent to the state machines whatever we have learned in the digital electronics paper under asynchronous machine and synchronous machine. So how to develop a state transition diagram from the Trellis diagram? We know the levels A, B, C, D. So I'm going to mention it as A, B, C, D. A is moving to A. A is moving to A. Under the condition input is 0, output produces 0, 0. Wherever you have input 0, you mention it as a darkened line. Whenever we have the input 1, we mention it as dotted line. A is moving to B, 0, 1, under the condition 1, 1, 1. A is moving to B, dotted line, because it is representing input 1 and output is 1, 1. Okay. Next we go for the level 2, 1, 0. It is representing B state. So go to B state. B is moving to C under the condition input 0, 0, 1. B is moving to C under the condition 0, 1. Input B is moving to D Under the dotted line, it means that it is input 1, output is 1, 0. It is moving to dotted line 1, 0. Clear? Now we move to the next level, C. You go here, C. C is moving two conditions. One is it is going to A, next it is moving to B. C is moving to A, C is moving to B. So B dotted line, therefore it is 1, 0, 0, 1, 0, 0. It is moving to A under the input 0. So straight line, 0, 1, 1. Next we move on to D state, D. D is moving to two conditions, C and D. So D is going to D under the level input is 1, therefore dotted line. D is going to D under the dotted line 1, 0, 1. D is moving to C under the input 0, 1, 0. So D is moving to C under the input 0, output developed is 1, 0. So all these three things, what we call it as a truth table. From truth table we'll develop a Trellis diagram, and indirectly this Trellis diagram will develop a transition. All three are interrelated. Only from this truth table we'll define these two diagrams, which says about how the convolution codes are being generated with the help of the convolution circuit block diagram developed for a encoder circuit under the configuration 2, 1, 2. Thank you.